I had a comment posted on one of my videos by Mr. Elbert. I'll put it onto your screen in case you missed it. He's asking, can you work out the distance, the straight line distance from your location to the summit of a mountain if you don't have a map, you only have a compass? Also, how long will it take to get there? I think that's a really good question, because it can be extended to other things, such as how do you work out the height of a mountain if you don't have a map, you only have a compass? So what I'll do is I'll give it a go answering his question. Thank you, Mr. Elbert. I'll go down there to the bottom of these steps and I'll try and balance this camera on a rock or something, and let's see what happens. Hopefully the camera will stay where I've balanced it. Let's see. If the camera falls over while I'm filming, you'll have to go and watch a real YouTube channel, a more professional. So we know that Mr. Elbert has fallen out of an aeroplane somehow, and he's looking at a mountain and he knows the height of that mountain. He wants to work out what is the direct line distance from his position to the summit, and also how long is it going to take him. You can also use this same type of thing to actually get the height of a mountain that you don't actually know. And all we're going to do today is we're going to use one of these, a tiny little compass, really cheap. You don't need anything fancy. And we're going to use this to get the angle from here to the summit. If your compass has an inclinometer on it, you can use that. But this one doesn't have one because, as I said, it's really cheap. So all I'm going to do, set the dial on 90 or east, and then point the edge of the compass at the summit of the mountain. So it's up there. Holding the compass really still, I'm going to rotate the bezel until the orienting arrow is pointing straight up into the sky. It's vertical as I can get it. I'll put this onto your screen and I'll zoom in when I get home so you can see what I'm doing. Now, the compass now is on 65 degrees. It started at 90 and now it's on 65. So 90 minus 65 is 25. So I'm looking up from here to the summit of the mountain at approximately 25 degrees. Now, how does this help? Well, there are a few ways to calculate distances, but today we're going to keep things as simple as we can. So let me draw you a picture of a mountain. So let me find a clean sheet. So here we go. Here's a mountain. Once again, I'll put a graphic on your screen when I get home so it's a bit neater. But for now, there's our mountain. So all mountains look like that. So it has a base, it has sides, and it has a height and a top. Now, if we cut this mountain in half, like this, what we've got is we've got two right-angled triangles. So let's draw, so this is the 90 degrees section here. And the 25 degrees, don't forget, where we're stood, is there. So obviously this diagram isn't to scale, so please don't post comments about that. So it's 25 degrees from here to the top of the mountain. 25 degrees, this is our reference angle. I'll label the sides of the triangle just like your school maths teacher used to do. And yes, I know, some of you were always asleep in math classes. But if you just look at all the fun you could have been having if you'd have stayed awake. You know. So in our triangle here, the vertical section above the 90 degrees, that is the height of the mountain. And that is called the opposite. So I'll put an O there. The bit that we want to know from the reference angle, where we are, to the summit, that's the hypotenuse. Now, the bit at the bottom is called the adjacent, but we don't actually need that much today. So we're trying to work out what the distance is from here to here, and we know the angle. For today, let's imagine, just to make it interesting, that we can see two mountains in the distance. And don't forget, Mr. Elbert knows the height of these. So let's draw two mountains. So there's our first mountain, and there's our next mountain. So one of them is bigger than the other one. Let's say that this is 345 3, 4, 5 meters tall, and this one here is, I don't know, 6, 7, 8 meters tall. So there we've got 2 mountains. I'll put this onto your screen in a little bit, a bit neater. We'll use our compass, again, in the same method that we used earlier on, to get the angles from here to the summit of both mountains. The first angle, let's say that it's 25 degrees, because we've already done that. And the second angle, which we'll have that as 37. So there you go. Those are both our reference angles. Just draw them in. So we've got 2 mountains. The first is 3, 4, 5 meters tall with a reference angle of 25. And the second mountain is 6, 7, 8 meters tall, and it's got a reference angle of 37. Yeah, dead simple. Now, whilst we're remembering our school days, do you remember a strange word that you were taught in your maths class when you first started doing trigonometry? Sochato. Sochato. Don't panic if you don't remember it. We're only interested today in the first 3 letters. S-O-H. Okay, that's all we need to think about. Now, Sochato, what that does is it tells us that there is a relationship between the angles of a triangle and the length of the sides and lots of other things. But for today, we only want SOH. And that means, or that stands for, the sine of the angle is equal to the length of the opposite side divided by the length of the hypotenuse. We're getting there. But even that may sound slightly complex if you haven't been at school for quite a few years. So let's simplify it even more. SOH just means that a straight line from our position to the summit is equal to the height of the mountain divided by the sine of the angle. See, it's getting simpler. So to start with, let's look at our first mountain, the 3, 4, 5 tall mountain, and the angle with 25 degrees. I'll use my calculator on my phone just to make life simple. If I can find it, bear with me. Here we go. So here's my calculator. Put it in scientific. So don't forget, it's 3, 4, 5. So I'll just tap it in here, so hopefully you can see it. Oops, it's gone off. So 3, 4, 5. Why have I got 4? 3, 4, 5 divided by the sine of 25 equals 816. So from here, a direct line to the summit is 816 meters. There you go. When you were at school learning trigonometry, did you ever think that you would be able to use it in the real world? Well, I think this answers that question. Yes, you can. So let's do the same with the second mountain. Or if you want to, you can pause the video and give it a go and see if you get the same answer as me. But if you don't want to do that, get your phone out and we'll do it together. So let's cancel that. So don't forget, the second mountain is 6, 7, 8 meters tall, and it's got a reference angle of 37. So all I'm going to do is I'm going to do 6, 7, 8 divided by the sine of 37, close the brackets, equals, and I get a distance of 1,126 meters from here to the summit. If you pause the video, did you also get that? 1126 meters? If you did, well done. So we now got the distances from here to the summit, which is Mr. Elbert's question. So what about the travel time? How long is it going to take us to walk from here to the summit? To get the travel time to the summit, we're going to use something called Naismith's rule. Now, I've done another video which describes Naismith's in much greater detail, so I'll put the link in the description box if you're interested. Today we're going to simplify it. We're going to say that we walk at 4 kilometers an hour, and we're also going to add 10 minutes for every 100 meters that we rise, every 100 meters of ascent. So let's work it out. For the first mountain, we need to walk for 816 meters, but we'll simplify this and we'll just call it 800 meters. If you walk at 4 kilometers an hour, then every half an hour you're going to do 2 kilometers, 2,000 meters. Every quarter of an hour, you're going to do 1 kilometre, which is 1,000 metres. And this means that each 100 metres will take you 1.5 minutes. So to walk 800 metres will take you 12 minutes. I told you, maths isn't complicated. Now, during your walk to the top, you're going to go up by 345 metres. But we'll make this easy. We'll call it 350 metres. Now, we need to add 10 minutes for each 100 metres of rise. So going up 350 metres, we'll need to add 35 minutes to our journey. So the total time from your position to the summit will be 12 minutes for the distance, 35 minutes for the rise, and that gives you a total of, I should have worked it out, 47 minutes. Okay, so what I want you to do now is pause the video and see if you can work out the travel time to the second mountain. Don't forget that the distance was 1,100 meters and the rise is about 700 meters. So pause the video and see if you can work it out. Did you get it? Did you get somewhere around 1 hour 27 minutes? If you did, well done. That's 16 or 17 minutes for the distance and 1 hour 10 minutes for the rise. So well done if that's what you got. And there you go. With nothing more than a compass and a bit of triangle thinking, Naismith's rule, and of course my mobile phone calculator, you can work out both the distance and the time to the summit, assuming once again that it's in a straight line. So if your school teacher ever told you that maths is useful, I think all this proves it. You know, and your teacher may have also told you that it'd be useful one day, even trigonometry, and this proves it. So now let's have a look at how you work out the height of a mountain if you don't know what it is. So don't forget that on the first two we knew what the height of the mountains were, so it made it a little easier. Okay, I will admit the last two examples were very easy because we knew the height of the mountain. So we only needed the distance. But what would you do if you didn't know the height of the mountain? And again, you only had a compass, nothing else. Well, let's go back to your school days and the maths lesson that you slept through. Let's draw our mountain again. So here we have, so there's our mountain, and we'll cut it in half. So we've got two right-angled triangles. Yep, that's what it looks like. If you hadn't been asleep through your maths lesson, you would remember that there is a relationship, as I said earlier, between the angles of the triangle and the length of the sides, all the different sides. I'll write them on, don't forget, hypotenuse, opposite, and the adjacent. And we can use this relationship to work out the height of our mountain, which in this case is the distance from here to here. So it's the length of the opposite side of this triangle. Just as a quick recap of what your maths teacher told you while you were asleep, don't forget Sochatoa, which is S-O-H-C-A-H-T-O-A. The first part, SOH, is the sine of the angle equals the length of the opposite divided by the length of the hypotenuse. The second part, which is CAH, the cosine of the angle is equal to the length of the adjacent divided by the length of the hypotenuse. Okay. Do it all in one go. And the last bit, TOA, is the tangent of the angle is equal to the length of the opposite divided by the length of the adjacent. Now, here's the thing. Do you need to remember all that? No. I'll qualify that. If you're still at school, yes, you do need to remember it. Otherwise, you'll fail your exams. If you've left school, maybe decades ago, no, you don't need to remember it. The only bit that we're interested in today is the CAH section. Don't forget, that is the CAH, which is the cosine of the angle equals, so the cosine of this angle equals the length of the adjacent, which is this section here, yeah, divided by the length of the hypotenuse. But we don't know what these are. We don't know what the angles are or anything. So let's work out how we do it. for our mountain. And because you're doing some maths, I do appreciate that once again you're having so much fun. You just can't believe it. What a brilliant video. You thought it was going to be boring, but it's not. It's amazing. Maths. So, just one point. We're not trying to work out this height above sea level. There. We're only trying to work out the height difference between our position and the top of the mountain. The first thing you need to do, again, is take an angle to the summit from your position using your compass. If you've already forgotten how to do that, then rewind the video, watch that bit again, and then come back to this. After that, what you need to do is take a normal compass bearing from where you are to the top, okay? And then you're going to follow that compass bearing. If you don't know how to take a compass bearing and follow it, I've done a video showing how to do that. I'll put the link in the description box. But for today, what you can try and do is just walk in a straight line towards the summit, okay, and then follow that. You're going to need to walk for at least 100 meters, or better still, 200 meters. The longer you walk for, the more accurate the height calculation. If the ground's quite flat, what you could use is pacing. Again, I'll put the link to the video on how to do pacing in the description box. But again, just for today, what you could do is count every time your left foot hits the floor and then walk for 130 double paces, because that's the average for most people over 200 meters. When you arrive at your 200 meter mark, take another angle to the summit. Once again, if you've forgotten how to do that. So let's say that your first angle was 23 degrees and your second angle after you walk 200 meters was, I don't know, 25 degrees. So now what we're going to do is we're going to use our mobile phone calculator once again. And let's have a look. Let me turn it on. Hang on, here we go. Get it up. So we've got our mobile phone calculator. What I'll do is I'll put this on the screen as well so you can also, follow it like that. But have a look at the calculator. The first thing to do is to put in the distance that you walked. And in my case, or our case, it was 200 meters. So we're going to put in 200 meters. Next, we're going to multiply this by the tangent of the first angle times the tangent of the second angle. So because we're going to be using the results of the calculation, we're going to double tap the brackets so we get two brackets. And then it's just tan, what was it? I've forgotten the number now, 23. So tan 23, close the bracket, times tan 25, and close the double brackets. And you should have 39.5 somewhere on your screen. Hopefully you can see that. The next thing we're going to do is we're going to divide this 39.5 by the tangent of the second angle minus the tangent of the first angle. Is your head hurting now? It's not difficult, honestly. So we click the divide, double brackets again, because we're going to get a calculated result. Tan 25, close the brackets, minus tan 23. Now we're going to close the double brackets down, and there is your result. Hopefully you can see that. Hopefully. We've got 946.3 meters. So let's go back to our brilliant graphic. So here we go. So we've got a hill. We've got a mountain. There's our mountain. And we'll divide it into, we've got two angles, 23 and 25, and we did all our calculations, so we now know that from there at the top to the bottom of that was 946 meters. I told you, maths is easy and it's fun. Just as your school maths teacher told you it would be. I'll put those two functions up on the screen that we've used today for getting the distance to the top and also getting the height of the mountain. In case you ever fall out of an aircraft and all you've got in your hand is a compass. You never know. These things do happen. So hopefully you enjoyed this, and hopefully that answered Mr. Elbert's questions. So thanks for watching.